This video is made by Group P. We are Aditya, Joseph, Mo, Mohammed, Wang and Valen. Hello everyone. Welcome to watch our learning resource video. The topic is types and patterns of innovation. We starts with an introduction of different types of innovation, followed by comparisons between them. In second part, we will learn what is technology S-curves, how can it be used in technology improvement and diffusion. Moreover, its advantage and disadvantage as a prescriptive tool. Finally, we will discuss the technology cycles. That is how technology was born, mature, and replaced. Let's start with the case. The world's cheapest car, Tata Nano. Ratan Tata, chairman of India's Tata Group, had a vision of an affordable car for the Indian masses. Following an incident, he narrowly escaped running over a poor family, which had tumbled from a moving scooter. This car was to be priced around $2,200. It took 5 years and roughly 800 suppliers to successfully complete the Project Nano, as the car was named. When the project had taken off, the cheapest car available in the market was the Chinese QQ3. Priced at $5,000, it became certain that benchmarking against existing cars would not be of much success, so a change in the comparison scheme was brought about. The change was to benchmark the properties and systems of the car against the two-wheelers. Many things which were taken for granted during the construction of a car had to be thought of again. Like reduction in the number of cylinders used in the engine, would reduce both the cost and weight of the car, exclusion of electric windows, anti-lock brakes, and airbags. With many challenges involved making the production extremely difficult, many of the suppliers took this as an exciting challenge. They had to design with the aim of achieving reduced weight and cost. Many came up with unique ideas such as a hollow steering column, and a single fuel injection valve. Even the power steering was not necessary because of the low weight of the car. Radio was not included into the base model, but could be bought separately. Everything about the car design had to be redesigned and thought of again, in order to realize the Nano. Ranging from the car's frame to major power system. However, from the innovation perspective, the car was an unmitigated success, which showed the world that a dramatically less expensive automobile was possible. Now let's move to our first part. Types of innovation. There are 8 different types of innovation. Each requires different kinds of underlying knowledge and have different impacts on the industry's competitors and customers. However, they are usually categorized into 4 dimensions, which are product versus process innovation, radical versus incremental, competence enhancing versus competence destroying, and architectural versus component. This is the first dimension. Product innovation are embodied in the output goods or services, while process innovation is an innovation in the way that business conducted, which are often oriented toward improving the production. New product innovations and process innovations both occur in tandem. New processes may enable the production of new products. New product may develop new processes. And a product innovation for one firm may simultaneously be a process innovation for another. A typical example for product innovation is Honda's development of new hybrid electric vehicle. Now this is the second dimension, radical innovation versus incremental innovation. Radical innovation could be conceived as the combination of newness and the degree of differentness, while an incremental innovation might not be particularly new, or involve only a minor change from existing practices. The radicalness of innovation is sometimes defined in terms of risk. It is relative, and may change over time, on with respect to different observers. An innovation that was once considered radical, may eventually be considered incremental, as the knowledge base underlying the innovation becomes more common. The third dimension is competence enhancing innovation, versus competence destroying innovation. An innovation is considered to be competence enhancing, if it builds on the firm's knowledge base, while an innovation is considered to be competence destroying, if the technology doesn't build on the firm's existing competencies, or render them obsolete. The last dimension is component innovation versus architectural innovation. An innovation is considered a component innovation if it entails changes to one or more components, but does not significantly affect the overall configuration of the system. While an architectural innovation entails changing the overall design of the system, or the way that components interact with each other. Moreover, these two types of innovation require different knowledge about the components and system. As we have a basic knowledge of different types of innovation, now let's move to the second part. Technology S-curves. S-shape curve is introduced to represent the rate of technology's performance improvement, and the rate at which a technology is adopted in a marketplace. Although S-curves in technology performance and technology diffusion are related, improvements in performance may lead to faster adoption, and faster adoption may motivate further investment in improving performance. But they are fundamentally different processes. S-curves in technology improvement is a plot of technology's performance versus the amount of effort and money invested in the technology. It shows slow initial improvement, then accelerated improvement, then diminishing improvement. In early stages of a technology, the performance improvement is slow, because the fundamentals of the technology are poorly understood. Great effort and time may be spent in searching different paths for improvement. As soon as the scientists or firms gain a deeper understanding of the technology, improvements begin to accelerate. Technology begins to gain legitimacy, attracting further developers. This encourages the researchers to develop ways to measure or assess the performance of the technology and concentrate only on those activities that provide the highest performance, enabling a rapid increase in performance. However, in early stages, the effort invested in new technology may reap lower returns than invested in the current technology, and firms are often reluctant to switch. At some point, diminishing returns to efforts begin to set in. As the technology begins to reach its inherent limits, the cost of each marginal improvement increases, and the S-curve flattens. We also need to consider the aspect of the relationship between the time and effort. If the invested effort is not constant over time, then the resulting S-curve can obscure true relationship. If the effort is relatively constant over time, plotting the performance against time may yield the same relationship as the performance plotted against effort. Generally, new firms entering into the industry adopt new technologies, which makes it difficult for the older firms to decide over a switch to a new technology. If the disruptive technology provides a better performance potential for a given effort, in the long run, it is likely for the older firms to displace the incumbent technology, but the rate at which it happens varies significantly. S-curves can also be used in technology diffusions. Technology diffusion refers to the spread of technology through a population. It's obtained by plotting the cumulative number of the adapters of the technology against time. The adoption accelerates as the technology becomes better understood and utilized by the mass market. Eventually the market is saturated and so the adoption rate declines. Technology diffusion takes far more time than information diffusion. Although some knowledge might be transmitted using manuals, other aspects to utilize the potential of technology might be built up only through experience. Many potential adopters of new technology will not adopt it until the knowledge is available to them, despite their awareness of the technology and its potential advantages. S-curve can be used as a tool for predicting when a technology reaches its limits, and as a prescriptive guide for whether and when the firm should move to a new radical technology. Firms can use investment and performance data of their technologies, or the overall investment, and the average performance achieved by multiple producers, which will help assess a technology. Moreover, managers can switch S-curves by acquiring or developing the new technology. However, there are limitations of S-curves model as a prescriptive tool. First, it is rare to know the true limits of a technology in advance. Second, the shape of a technology's S-curve is not set in stone. Unexpected changes in the market, component technologies or complementary technologies can shorten or extend the life cycle of a technology. Finally, firms can influence the shape of the S-curve through their development activities. Now let's move to our last part, the technology cycle. In the last S-curve part, we have known that there are 5 categories of adopters. They are innovators, early adopter, early majority, late majority, and laggards. With these definitions we could have a knowledge of technology cycles. As demonstrated in the S-curve part, each technology will have 3 periods. Initial period of turbulence, rapid improvement and diminishing returns. However, the technology itself will also be replaced by more strong and innovative technologies. And the others will also meet the S-curve, which is the technology cycles. It shows the standard cycle of technology. In the beginning, the technology born, or replace the old, with uncertainty and completion, which is the era of ferment. Then it will come into a period of being accepted by people and commend the majority market, which is dominant design selected. And next in the era of incremental change, firms are usually focusing on efficiency, penetration and lower costs. And finally, it will come to the end, which is technological discontinuity, and replaced by some new technology. That would be the end of our video. Thanks for watching.